Good morning, physics people, and welcome to the beginning of our car collision unit. The first thing that we're going to tackle in this unit is distance versus time graphs. So you thought you got out scot-free from graphs. Not. They come back and they haunt you. This one in particular, I don't think you'll have much trouble with, but if you need help, this video is here to help you. This one is going to specifically go over activity A of the gizmo that I have assigned for you. The next video is for activity B. So let's go ahead and get started. First thing you should do is set up your screen. You should have it set up just like mine, where you have the document on one side that have the instructions and then the gizmo itself on the other side. Let's review some key vocabulary first. The two words we're going to focus on today include speed and the y-intercept. So let's look at speed first. The definition says the distance an object travels in a certain amount of time. Think about in your car, right? Your speed is measured in miles per hour. Like, think about that unit really quick, like miles per hour. It's literally how far can I possibly travel in a very specific amount of time? How many miles can I travel in an hour, right? That's speed. The other term that we care about is the y-intercept. This is a mathy term. You've seen it in algebra, I'm sure, when you talk about like y equals mx plus b, and you're like, b is the y-intercept, right? And if you don't know what I'm talking about, you'll get there. Y-intercept is just the point on a graph where the line crosses over the y-axis. Okay, so y-intercept, it crosses the y-axis. And that's going to be important to us when we're trying to figure out some information from our distance versus time graphs. So knowing that, let's jump into some things. The prior knowledge questions is on you to do. I'm not going to help you with those ones. Make sure you do answer them though. Then let's get to the gizmo warm-up. It says the gizmo shows a graph and a runner. Okay, so the graph is kind of in this nice green color. The little runner guy is red and is down below. We can control the motion of the runner by manipulating, meaning we can change parts of the graph and the runner will do different things. It says check that the number of points is 2, good, and that runner number 1 has both show the graph and show the animation checked. So they are good. It says that the graph should look like the one at the right, which they match if you haven't touched anything, so then you're just like good to go. We are going to click the green start button on the stopwatch, and we just want to observe what's happening with the little animation guy that's like running across the bottom versus what's happening on the graph. So let's go ahead and click that green button and make some observations. Run, 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 run. And ta-da, that's the end of the simulation. That was not very exciting. However, if you missed it, just hit the red reset button and then the green one again, and you can watch it again. Lots of different answers you can put here. Whatever observations you make, go ahead and put them down for question number 1. All right, we're going to click the red reset button again, and this time we're going to use the vertical green probe on the graph so that we can see a snapshot of the runner at any particular point in time that we choose. So if I take this green probe, this is what they call a probe, and I just drag it along, right? I'm dragging it along the x-axis, which means I'm choosing specific points in time during this little guy's run to see what position is he at, what distance. So like if I drag it to the number 2 on the x, that means at 2 seconds, that runner should be at 20 meters. And I can drag it some more. And if I'm like, okay, what about at like 3 seconds? And then it's like, oh, is that like 30 meters, right? And that matches the simulation, because if I look, is the little guy down there at 30 meters? Yeah, that's right. So that all matches. Now, knowing that, I'm going to let you guys answer A, B, C, and D, okay? Now let's get into activity A. Dun-dun-dun, runner position. So as always, with all your gizmos, make sure that you read the get the gizmo ready, because sometimes there's very specific instructions, all right? Get the gizmo ready. Hit the red reset button. Bloop. And the number of points is 2, so we're good. In the gizmo, run the race, because who's he racing against? Many times with a variety of graphs. The red points can be dragged vertically. Pay attention to what the graph tells you about the runner. So the 2 points we have, there's one on the left-hand side of our graph here. Right now it's starting at 0. And let's just shift that up and down vertically. If we go up, notice what happens to the runner. Okay. So we can see a change in the runner by moving that dot. Let's move the other side. If I shift it down and back up and back down, I don't see any changes in the runner right away. So this is where you need to run some tests. Originally, it was here at 40. I'm going to drop it down to like 30, and I'm going to hit run. I'm going to observe the runner. Aha. Okay, so before, when it was at 40, the runner went all the way to 40. Now at 30, the runner only goes to 30. So my prediction is if I put this to like 10, the runner's going to be like super slow running to like 10 meters. So painful to watch. Okay. So patterns that we see. If we change this dot here, that's directly on the y-axis, we are changing where the runner starts, right? If I pull it up to 10, the runner, let me hit reset. If I pull it to 10, the runner starts at 10. If I pull it to 20, the runner starts at 20. If it starts at 30, if it starts at 40, right? That represents where the runner starts. If I drag this one changes where the runner ends. So if it's at 10, the run ends at 10. If it's at 20, it ends at 20. And 40, it ends at 40, okay? So there's the pattern. That should help you answer a couple of these questions. Oh no, my son is up. Go fast. Let's go down a little bit to question number 5. Okay. It says in the gizmo, set the number of points to 3. Let me click reset here real quick. So that means instead of 2 dots on our graph, 1 at each end, we're going to have a third one kind of in the middle there. So I put a third point in there. So notice that my graph has that third one in. It says create a graph of a runner who starts at the 20-meter line, runs to the 40-meter line, and then finishes at the 30-meter line. So the two things that should be very easy for us is the starting and the ending. The runner has to start at 20. So that's definitely going to be right there. The runner has to end at 40, which is definitely going to be right there. But then we have, 30. The runner ends at 30. But then we have this middle piece that we need to place somewhere. And there's a variety of ways that you can do this. The runner is going to run from 20 to 40. That could be done very quickly. Oh no, I guess we can't. Just kidding. Forget everything I said. It can only go right there. I didn't really mess with this earlier. So I thought maybe we could make it go faster or slower, but we can't. Some things you just can't do. Life's not fair. It's okay. All right. So starts at 20, runs to 40, goes back to 30. If we want to test that we did our graph correctly, hit the green button. And let's see, it starts at 20, runs to 40, goes back to 30. And it's good. That's exactly what the scenario is. I need to delete this part because there actually isn't more than one way to do it. All right. So how do we get this graph onto here? When you click this image, there's a button called Edit. Click on that. It's going to pull up a drawing box. You might have to zoom in a little bit here, which if you click on let me pull it up again. There's a magnifying glass. Click on that. Click on zoom. And then you can, go to 100. Maybe that's big enough. Nah, go bigger. Go 200. Okay, there we go. That looks good. So then you can use this line feature to draw a line on your graph, similar to what the line actually is on your graph on the gizmo. So click line, and then notice it has to start at 20, and then it goes up to 40. Okay, and you can change the color, and you can change the width, and then you can draw another line that goes from 40 to, oops, not that one. You crazy? I want to draw another line here down to 30. Perfect. That looks good. And then you have to click the little arrow guy again, because otherwise you're going to draw lines all over the place, and you don't want to do that. So click the little arrow. All right, and then click save and close. And look, it's there. Da-da-da. Okay, now I do want to backtrack just one question. I got distracted when my son was kind of crying. Question number 4 talks about the y-intercept. Now remember, we said this was a mathy term. It refers to when the graph crosses over the y-axis. Y-intercept, y-axis. So if you look at our graph on our Gizmo, the y-axis is the one that goes up and down. The place where the graph crosses over the y-axis, remember we said the pattern there was that was the starting position for the runner. So the y-intercept is the starting position for the runner. Okay, that should kind of help you out with some of your stuff for question 4 and the last part of question number 5. Okay, so I think that gives you a pretty good overview of activity A. Sorry, it was a little bit jumbled there for a hot second. Sorry, everyone makes mistakes. In the next video, I'm going to go over activity B. So if you're good with activity A, continue on. If you need help with just activity B, sorry for watching the whole video. All right, email me if you need help.